Yeah, we're live, 6:31. I'm early or late if I was starting at 6, early if I was starting at 7, but this is when I'm starting. The dogs are barking. They're walking perimeter right now. Actually, one of them or both of them have a little girlfriend next door. They have there's a cute little girl puppy that our neighbors got, and so now they talk to each other through the fence. So you try not to stifle that stuff. I told them, look, if you like her, you need to go over and introduce yourself and meet her parents. Show them what a good boy you are. Show them you know how to sit and do all those things. Tonight we're going to talk about a couple things. One, the video that I just posted. Hopefully you guys have taken a look at it. It is on trick flow head shootout, 245 cathedral port versus 255 rec port, and the guys at Brian Tooley Racing, even as it turned out, the compression was even on them because they both had within, I don't know, half or 1 cc of the same size chamber. So it worked out very well. And when I ran the test, or when I was comparing them, we got to compare them with 2 different intake manifolds, because while they had the heads on there, they ran a few different series of tests on each one of them. So we could go back and look at the data and compare the 245 cathedral port head with 2 different manifolds, and then the 255 rec port head with 2 different manifolds, and do some cross pollination there, and we could see which ones they did and how each one of them did. And it was pretty interesting. I've compared this a couple of times, not directly those particular heads, but I've run the factory heads, like the factory. In fact, I ran a 706, a 799, and then the LS3 head, also the 317 head. And whenever we do that, whenever we run the factory stuff, obviously we have to run it on a combination that has a big enough bore, like a 6-liter, which is what I did. Whenever we do that, the factory LS3 or LY, in this case was an LY6 head, makes more power because they flow 315 CFM and the others only flow 250. So if you're asking it or putting it on a combination and asking it to flow to support a power level that needs that kind of flow, make lots of power. And that's exactly what happened. The rec port head did better at the top. It didn't do as well down low. Port volume, valve size, all the rec port guys want to direct their attention to compression, but it's not just compression, it's other things. And then I also did a test where in a couple of instances, and including these in the video. One, we ran a stock 317 head, and this was on a 408. And then we ran a factory LY6 head, and then we ran an aftermarket head. In this case, it was the Airflow Research 245 head, only because that thing was already readily available, something that I had from the previous test. I wouldn't have picked the 245 head for that combination. I would have picked something else. But it showed that, hey, look, when you go from a stock head, 317 head, in my opinion, the least powerful of the heads, of the factory heads, and then to a LY6 or LS3 head, the most powerful of the factory heads, you get a good step up in performance. And then if you go to some sort of aftermarket head, which is kind of what I was showing, you go to some sort of aftermarket head, in this case, an Airflow Research 245 head, you get a big gain. And I showed that once again. That one was on a 408. The next time I did the similar test, I did it on a 6.2 liter I did it on a 6-liter. I did it on the LY6. So we did the same thing. I ran, and I didn't show this on all of them, but the one that I showed in the video is I ran a 799 head, the best of the cathedral port heads, and then the rec port head, LY6, LS3 head, and then compared those two on this 6-liter, cam 6-liter, if you will. And just as it did on the 408, the rec port head makes more power than the cathedral port head. It does that. It made less power down low, which they typically do. And then I showed once again, hey, let's put an aftermarket head. I had a set of 225 trick flow heads and put those on and ran it. And when we did that, the trick flow head, the aftermarket CNC head, made more power than the factory rec port head did. Not surprising. It should do that. But once again, you have the rec port guys saying, well, but that's not fair. You didn't equalize the compression. Yeah, the same thing when I do the 706 and the 799 head test. No, you got to equalize the compression. No, I don't really have to. All I do is test the stock heads. And so I tested these heads the way that they came from the factory versus the way that this 225 head came from the factory, in this case, trick flow. And so we ran that and it did well. But again, so there, we didn't equalize the compression. So in this test, in the video, you could see 245 head, a trick flow head, the cathedral port head versus a 255 head, both of the same manifold, so that people don't get to complain about that. And then both of the same compression within 1 cc of the head. And so you get to kind of see what they do. And in this case, and especially if anything, yeah, guys could argue, and I'm sure that we'll get comments to that effect, that running this test on a 700 horsepower or 700 plus horsepower 427 high compression big cam kind of thing favors the one that has the most airflow. And in this case, and then this is something I didn't talk about, and this is something I do want to talk about on the live feed. One of the things that, if you look at the head flow on these heads, the cathedral port head flows very well, in fact comparable to the rec port head, up to about 600 lift. Now at 700 lift, the rec port head flows 380, so it flows a lot. But at 600 lift, the rec port head only flows about 10 CFM more than the cathedral port does, 350 versus 360 something. Well, our camshaft was only a 618 lift cam. So our camshaft meant that the heads were being flowed basically in a range where they were fairly comparable. And both of them being at least 350 or 360, we have a situation where they'll both should theoretically support the power level that we were at. And they did. They both had the ability to make over 700 horsepower, which gives us, puts us in the sweet spot of the 2 horsepower per peak CFM rule. It's just more of a guideline than a rule. I think that had we gone up in more displacement and certainly more cam lift, that the rec port head would have even come into its own even more. As it turned out, it made more power than a cathedral port head, but by a little bit, by about 10 horsepower. The interesting thing was that it had a fairly consistent gain all the way through the RPM range. And Brian and I talked a little bit about that today when we were on the phone. But I think, like I said, had we added lift to this thing, maybe 1.8 rockers or a camshaft with not this crazy duration split, this nitrous cam, or something that was a 650 lift, more in line with what you'd kind of see on an LS7 head. Those tend to be higher lift things because of the 1.8 rocker. But if we had that kind of camshaft and we were utilizing the improved airflow at the higher lift values that we got from that we had from the LS3 head, I think it would have skewed it even more. And if this motor would have been, instead of a 427, would have been a 440 or a 450 or a 460, I think we would have had even more. But like I said, if I was doing that, I probably, and I was building a motor, I would have tailored it with more lift, because those particular heads could take advantage of that additional lift. So I think that that's probably something that I would have tried, and it would have been interesting. This combination, this 427, they also ran at Brian Tully Racing. They also ran with LS7 heads. So, and it made more power with the LS7 heads. As a spoiler alert, I may do that video, and so we can show that. I just need to get together with James and make sure that we obviously want to run it with the same, the LS7 head. I need to look and see what the chamber size is on the LS7 heads that they use, because they did use ported LS7 heads. I need to see what chamber they are, and I also need to see, when they ran the LS7 heads, did they run a cam? And naturally they would run it with 1.8 rockers. So did they run something that would have more lift with the LS7 because of the rocker ratio? So all those things need to be discussed. I wasn't there when they ran the LS7 heads. By the time I got there, we were already into the LS3 stuff, because we were using it to test all these different intake manifolds. So it was pretty cool to be there for at least the intake manifold testing. But there's a lot of information there, and there's a lot of stuff that I'd like to share. And it's good, valuable data for people. And thanks to James and Brian out there for allowing me to be there and do the testing with them, and then share some of this information, because it's really good stuff. So the other thing I want to talk about is, and we'll take a look at the, if you haven't seen it, we'll take a look at the thumbnail. So here it is for the guys that are here. If you're not here, you should have been here already. You should care. You should dare to be part of the program. But this is the thumbnail. So this is a 6.2 aluminum block LS3 with trick flow, the trick flow 255 heads on it, and then the Speedmaster stack injection on it. And we did compared the factory LS3 intake manifold to this stack injection, and this stack injection actually did very well compared to the factory LS3, at least on this combination. And we'll talk about that. In fact, I'll go ahead and show you guys the dyno results when we're in just a little bit. We'll talk about that. But so the poll for tonight would be for the guys that are here. Let's see. Okay, start a poll. Here we go. Knowing the tuning and air. Oh. So I get 100 characters to do this, and I just started typing the question that I wanted to ask, and it came out right at 100 characters. So that tells me that it's the right question for the poll. Would you run a stack injection on your street car knowing the tuning and air cleaner difficulties that are associated with when you pick that? So that will be our poll for today. Who would run the stack injection? It sounds good and it looks awesome. And in this case, we'll take a look because it also makes pretty good power. So I'm going to go ahead and show you the dyno curves here, and you guys can take a look at that. So we're doing some cool stuff tonight. So these are the dyno results. You can kind of see the power picked up a lot versus the factory LS3. So we went from 574 or 5 horsepower to 605. So the stack injection added almost 30 horsepower. So it was quite a bit. And we see, and it picked up a lot of torque too, 533 foot-pounds versus 517 foot-pounds. And then we got some wiggling going on where our reflected waves are kind of, dancing back and forth. So that worked out pretty good. I want to make sure that our description here. Yeah, this thing had a cam in it. It had the 259 camshaft in it. Let's see here. So that one had, I just want to make sure that it had, yeah, both of them had the same heads. Yeah, 617, 624, 231, 239, and a 113. So you can see good power gains from that and definitely worthwhile. In fact, it was better from 4,800 or so on out, which is a good, it's a rare thing that we see on the factory LS3 stuff, that we see that much of a gain and then see it that early on in the RPM range. So the stack injection did work pretty well. We like that. Do Ford stuff. I have literally playlists full of Ford stuff up on the channel. So you could take a look at that. There's endless Ford stuff. So this did well. And it looks cool and it sounded great on the motor. It made good power. We had the stack injection camshaft on it, if you will, because, we always have the wrong camshaft in there. But so it'd be interesting to see how many people would run the stack injection. Part of the problem, as we always have with these things on a high ram or whatever, is hood clearance. So you're not going to fit this in a Corvette or a Camaro or maybe even a truck. Maybe it's only a sandrail kind of thing. And then the problem becomes getting these things tuned can be problematic with getting all of the things synced properly. And that's usually more of a function of not an IR design, but the particular IR that you're using. Are all of the things linked so that they don't, because you're grabbing one of them normally. A good system has a center pivot, so it's grabbing the center of the shaft and then is moving it. And so hopefully they all move synchronously. They all move at the same time. Sometimes with the way that the linkage is set up and being able to adjust them individually so that you get them all loaded and working in unison, that doesn't happen. So if you have one opening before the others, you have tuning problems. The other problem that presents itself with this type of stack injection is getting air cleaners on them. Do you just run it open and breathe dirty air and wear your rings out? Because that will happen. Or do you put air cleaners on them, and do they not look as good with the air cleaners, and do they restrict the power? We've seen that a lot of times when we're running the stack injection, that you do indeed hurt power with some different air cleaner assemblies. You know, do you put a box and a lid and a big filter on them like they do in the off-road stuff? Then you have a common plenum. It's not an IR, and you have all kinds of things you have all kinds of things, all kinds of considerations, all kinds of things that you need to think about, and changes that you need to make to run the setup, unless you're just running it in a sand rail. I don't know about sand going in there. That would not be a good idea. But so it's interesting. It's an interesting conversation, but they look good, sounded good, made good power, all of that stuff. You have definitely made enough money off this show to get a 7.3 new test mule. No, that's not the case at all. So, but nice try. It's nice that people outside of what reality is try to decide things. That's interesting. Chicago, I have a question. Why didn't you use 9391 octane when you tested the BTR intake manifolds, just like the other intakes? We used E85 on all of the testing on every one of the intake manifolds that we tested. Every one of them, from the stock one to the rod mod to everything. Every test that was run on that motor had E85 in it. Are Edelbrock heads not popular? They are popular. I have used in all the videos, Ford, Chevys, whatever, we've used Edelbrock heads on lots of different things. I think the BTR truck intake would compare to the Holley High Ram since they resemble each other so much. I don't know what you mean by the truck intake. Do they make a long runner or a longer runner truck intake manifold? If they did, we didn't test it. Are you buying any of David's garage cleanup stuff? No, I haven't even looked at that to see what was available. Van, you got some short blocks ready. 408 Gen 3, 429 LS7. Good. Run some dyno runs today. I didn't do any dyno runs today. I'm at home. 8 stack is always the best. It does look good, and I can never decide whether I like the straight up and down ones or the cross ram looks really good too. Sprint car filter, yep. Let's see. Just want to say thanks. Just finished my LS Swap 62 Bel Air wagon. Very cool choice. Torque Storm supercharger. Yeah, Matt's got some Torque Storms. He's working with the guys from Torque Storm too. I haven't heard anything from those guys in quite a while. I was hoping that they would supply me the bracketry for a Pontiac, but I haven't heard back from them. Maybe they don't like me anymore after all the testing that they did with Torque Storm stuff. I would think that they would. Richard's always going to show you guys the dyno results because Richard doesn't just yak at it, he backs it. He doesn't just yak it, he backs it. Nice yaks at it, backs at it. Unlike many of the YouTubers. 8 stack is very cool. Longer stacks with bolster bottom end, yes. No, you can, if you take a look, KR, if you take a look at the Hemi test that I did, I actually made my own stack extenders, as you will, just aluminum tubing. And originally I just sat them in the rest of it, and they wiggled around. And so we had to bolster my system a little bit, but it ended up working. And it did exactly what you think. When you go into longer runners, and you don't have to, we didn't change it a lot, maybe, I don't know, 4, 5, 6 inches or something. And I did it in steps, but you can see that the longer stacks definitely do change power production. I would run 52 millimeter Webers, but not stack injection. Okay. That thumbs up is not going to smack itself. Yeah, everybody hit the thumbs up. We got 85 people here and 31 thumbs up. Just kind of hurts my feelings a little bit. I've converted to a set of small block Chevy 2.5-inch Kinslers on EFI on E85. Idle is finicky depending on the temperature. Drivability, though, with a quality timing table. Do you have the Kinsler is converted to EFI, right? It's not mechanical injection, because that's going to be a little bit more problematic. Now, as a kid, we got an 8-stack injection small block Ford, and it came with a laptop with this ancient IndyCar software with a basic graph and slider. Sometimes you can make that work pretty well. Driving home from working on my Ranchero. Can't wait to drive it again. What year is the Ranchero? I like the early small ones. Those are cool. putting together a Gen 3 6-liter 408 with a single turbo. Not sure what intake I should run. Marty, I have 408 stuff up on the channel. The fast manifold, if you're sub 7,000 RPM on a 408, the fast manifold works really good. You could use the truck manifold that makes not quite as much as the fast does. But honestly, if you have a turbo and you select the turbo for what you're trying to do, you'll be able to do that with any of these manifolds. Just use a cheap one. Sprint car airbox hurts them less, I think. Yeah, if the airbox like they use in the trophy trucks too, also, it's just a big common plenum with a big panel filter on it, and that works pretty well. Sprint car airbox. I did triple Makunis. Who doesn't like that? Yeah, I did triple side draft Webers on my Z. What happened to 396 dyno testing? It's going to happen. I just haven't put the motor back together yet. Gen 5 BTR long runner truck intake manifold. Okay, I didn't do any Gen 5 stuff yet, but I will. Yeah, it's an Illinois 3rd gen car show pull-up. Cool. Looking at 275 Cosworth Vegas tomorrow for sale locally. Oh, cool. Those are neat. Just ask Torchworm. I will ask them again. Since the video is about IR, the trophy trucks now run big block Chevys with 8-stack injection. Yeah, we've run a couple of, well, the guys at West Tech have run some of the big block trophy truck stuff now. So far, I love the 4.6 engine in my 08 Ford F-150. It runs great, no smoke, plenty of power. Wondering what the big difference is of the 4.6 in my truck and the one I had in my 99 Mercury Marquis. What year is yours? An 08? I don't think 08's a 3-valve yet, is it? 300 horsepower. So that is going to be a 3-valve. Although I don't know when they did it in the trucks. Richard, I just got my parts today for my 6-liter LQ4. That's good. Let me know what happens. Richard, what's the status of the Big Bang 351? There's no status. I haven't done anything with that. At what point is it worth using Inconel exhaust valves? If you're going to run boost for extended periods, or I almost think I would think about doing that if I'm trying to run high horsepower stuff on pump gas, because you tend to take a bunch of timing out of it. And so the EGTs are going to be high. Inverted EFI, throttle blade area makes off-idle touchy. Yeah, the bigger the throttle blades are, and on an IR, you're multiplying that by 8. So it gets pretty touchy. I run IR on my hydroplane. Oh, very cool. We run our first event this past weekend. It was on top. Nice. What motor is that? Our gains from going from a 350 to a 383 proportional to going further to a 406. Is there a typical less because of lack of head flow? You can limit. You're going to limit if you have a stock head on there. Like let's say you had an insufficient flow head on there, going from a 350 to a 383, you're going to gain most of your power in the area where the head can still support that power output, so down low. And then the same thing happens with a 406. If you have a set of heads that flow 200 CFM or less, and you can make 400 horsepower, and you're only going to make 400 horsepower if you have lots of camshaft in it, but the gains will just be better down low, and then you won't get as much up top. If you have a lots of camshaft in there and or lots of cylinder head in there, then you could take advantage more of what the displacement change has to offer. 2008 in the trucks. Can you do more 4.3 videos, please? Forced induction combinations would be nice. That would be cool. Don't have any more 4.3s to do testing on. I would need to get one. You can set up the throttle blades with a cam and cable system. You can have a rising rate throttle linkage, basically. We've done that on things that have big throttle blades on them, and it seems to work pretty well. I have an aluminum 4.6 out of a 2001 F-150 for my Crown Vic. So that's an aluminum 4.6 out of a 150. And it has an aluminum block. In 2001? What was that? Did somebody put an aluminum 4-valve short block together and top it with 2-valve heads for the F-150? After putting new plugs in my 99 Mercury, it would blow away a lot of newer trucks on the road. Lighter, good rear end. Rising rate throttle body. Oh, not aluminum. Okay. Makes more sense. So how's our poll doing? 44% saying, would you run a stack injection? Yes. A little bit more saying no at 55%. And then now we're at top chat. I can go to live chat. So we're live. It's all the way live. Thanks for our help. I'm putting the 6-liter in an 04. Oh, Blazer Extreme. Okay, cool. I like the little S10s and little Blazers. Do you know an affordable EGT setup for LS with a Holley setup? Are you trying to log it with the Holley? I don't know what the inputs are. I've only ever run a dedicated EGT gauge like in my Mustang, I had one from Autometer. It was a gauge and sending unit hookup. So I don't know about but an EGT gauge is just going to be a high temp type K probably. Richard, what's a good turbo for my 6-liter 408 stroker? How much power are you trying to make? If it's 1,000, then an S475 or an S480-ish kind of thing, 78, 75, Gen 2, all of those would be good for it. Adrian, for 2 years, they had aluminum blocks for mileage in the F-150 WAP blocks, not Italian. Okay. My father's 1963 Ford Galaxy, very cool car, would sit and burn off the rear tires, burn a strip length of 3 telephone poles with a 390 engine. Good. Was it a 394 barrel deal? Was it a 390 GT motor? I'm not familiar with them putting the aluminum blocks in it. The match bot by Borg Warner is good stuff. The problem is you don't know how well the turbo that you get, if you get an expensive turbo, how well it matches what Borg Warner is saying that turbo does. You just don't know. Car was 63 XL 390 2-door. Okay. So let's take a peruse here. 1963 390 specs. Why are you doing that? Ford engine specs. They have a 300 horse version. 405 and a 406. That was good. That would be a good one. Average with 427 foot-pounds, that would be pretty sporty. So a 300 horse 390, that would be good. Didn't they have a higher horsepower version of that? Maybe later on they did. They're saying that they had a 375 horse high performance version in 61. Definitely need to look at that, right? In racing. Super stock stuff. Yeah, that's all cool, but $352, 361, 390. Let's see. 4V version was rated at 320. Got a 335 one in the Mustang. When the 390 was first ordered for 61 model, there was a 375 horse high performance version that featured an aluminum 4-barrel, cast iron header manifolds, 10.5-to-1, solid lifter cam. Many of these cars came with aluminum tri-powers. Oh, in the trunk. It was installed by the dealer. Raised the horsepower to 401 horsepower. That would be a really cool engine build to do to see what it did, to see if it actually did that. I wonder what camshaft. I wonder if they used the Le Mans cam. I wonder what camshaft. Does anybody know? Does anybody have any? Does anybody know what specs, what cam specs they used on that? I've gone from a tiny 62 millimeter to 132 millimeter. It's really educational to see the across the board power of the 62 versus the bang at 5200 on the 132. I have a 63 Galaxy when I was in the Air Force, but it had a 352 barrel. Yep. Police engines were solid lifters from the factory. 401 horse, 390 with a tri-power. After seeing Calvin do the 180-degree headers, I want to say it's a little complicated, but I'm sure it sounded really good. On all the intake tests, would add to the video if it showed the manifolds compared, discussed, and all. I still have no clue what the rod mod is. I showed photos of it. The rod mod is, and it showed that literally had a photo that showed the rod that they use, and it was on both sides. It's a rod that they insert into the manifold. First, they do porting in the manifold, and it's a rod that they insert at the bottom portion of each runner. And what they're trying to do, just like when we flow test a cylinder head, we do a clay entry with a kind of rounded edges to improve the flow going into the port. This rod mod is supposed to do the same thing. It's supposed to have a radius entry at the bottom part of the runner to improve airflow in, and that's supposed to improve airflow in and power out. 62 Impala SS 2-door hardtop, 327 Power Glide, 373. Nice. Ram trucks for police cars now. 390 engines did have oiling problems in the cam area from the factory. I get discussions like that about, oh, the Buicks, they're terrible. They need oiling problems. The Clevelands, they had oiling problems. I've never heard one. Was your IR test done with a manifold? We used a map sensor on it. That's how we tuned it. So we're at 43% saying yes and 57% saying no on our poll. Ram trucks and the Magnums and the, I don't know what the other cars are called, the Chargers. Challenge. No, Chargers, right? The map is reading all 8 runners because it had a common connection to all of them. Not that that would make any difference if we were at wide open throttle. Two JZs have terrible oiling past 1,200 horsepower. But it comes back at 2,000 horsepower. It's easy to visually, and because I don't care about idle quality and stuff, it's pretty easy to visually, when you go to wide open throttle on the stack injection, to know that all of the blades are, perpendicular to the airflow or parallel to the airflow. One of those. They're straight. 2,000 horsepower is a lot, but 2J blocks have done that, not the internals. because that would be difficult. 45 and 55. We want to see the yeses going. Have you ever driven a Cosworth Vega? I have not. I've ridden in a V8 Vega. I don't think that counts. 1969, a Ford with a state trooper was chasing another car, clocked the highway doing 157. The trooper was a Vietnam vet. What car was doing 157 miles an hour? Do you think an old school small block Chevy in any combo? Do you think one of those engines could run 11,000 RPM? Yeah, you could get those motors to run that engine speed. It just takes changing everything. Probably not changing the crank. And I mean, you'd have to. This would have to be a steel crank and forged rod and forged piston and all that stuff, and probably be, I'm assuming, would be a dry sump, and then would have a valve train that would allow it to do that. Want to see a Gen 3 Hemi do 10.5 like the drag pack motors? You mean run 1050s in the quarter? Is that what you're talking about? Oh, 10,000 RPM. Okay. What did they do differently on the drag pack motors? I mean, I know that they make more power, but what did Chrysler do to them to make them run that engine speed? It's got to be a lot of valve train stuff. Usually the short block part of it is not the problem. Usually it's valve train stability. I got to see, and I'm going to try to do a video on it. I put together stuff. When I was at Brian Tooley Racing, they were using the Spintron, and they were checking Hemi stuff. And so they were checking Hemi. They were doing Hemi push rod tests on the Spintron. So I thought that was cool. So I followed along and did a video. So hopefully I can put that Spintron stuff up. Right now I'm on the Avalanche 4L60, 4L80 swap. Got 513 gears with 37s. The swap hasn't been as easy as I thought. Need someone with a computer to do the tuning on it. It doesn't ever happen as easy as we think it does. Dennis, did you ask what block was used to make 2,000 horsepower? It was a turbo one, but I don't know. Maybe the non-turbo one is it the same? My father's 99 Lincoln Continental has been sitting for 5 years, has a 464 valve in it. 99 is the later, although I don't know about it in the Lincoln. Like the head says to go right through the other end of the block. Having big long holes in the block, do you think that weakens the block? I remember, I think it was, who is it? Pete Ardema, who does lots of weird 4-valve conversion things, had some external head studs because he had them. I think he was using Subaru heads on a Model A or something like that, and so they were external. It was really pretty cool, and because he does crazy stuff, and that was at West Tech. It was pretty impressive. Jack Stands just jumped off a live stream. Had a really good one myself yesterday. Good. But what did you guys talk about? Yeah, I'll see if I can dig up a photo of that. I think I took pictures of it. Some Mustang Cobras had 4.6 4-valve motors. Yeah, lots of them did. All the Cobras did. Can you bolt a 4-inch stroker kit into a 6-liter LS block? Yeah, you make a 408 out of it if it's 30 over, or less if it's not bored that far over. Depending on what stroker kit you get, you need to check and make sure that it's not hitting anything. Make sure the rods are not hitting the side of the cylinder walls. Sounds like a Garage 54 external headset. Pickens with Pickle was a 6% recycled, and Mater's Garage was on. Cool. We like what we like. Got to check stuff out. Cobra's had aluminum blocks and aluminum heads on the 4.6 stuff. So is everybody taking a look at the video that I put up today? No cathedral port rec port conversations. no rec port guys saying, you finally did it right, you even the compression out. I'm surprised I didn't get more comments like that. I haven't seen any yet, because I'd like to go on. That's an interesting thing. I get lots of people that are surprised. I get people that when they make a comment, they're like, well, I hope you see this, or I hope you read this. I'm like, I read every comment. Like, try to respond to every comment. Some of them I don't, because they're negative comments, and I just thank them for commenting and go on about my business. But I try to, if a guy has a question about a 5-liter Ford camshaft or an LS or whatever, I try to answer all of those. So I try to go in and do that. And it's, it's time consuming, but I like to interact, and I like to, I want the channel to help people. I want to give them information. And part of that is doing this, answering these questions. So when we do these kinds of tests, the comments that I got on the previous test were, oh yeah, it was just all compression. It's, same thing with the 862 or 706 and 799 heads. I'm a Mopar guy, but cathedrals are so tall and narrow. Yeah. Yeah, it is weird. They are significantly different than the big rectangle ports on the rec port stuff. Can you explain how camshaft specs will affect gas mileage? Yeah, if it makes a lot more power, it's probably going to hurt mileage. The thing that I look at mostly is if you have a change in idle vacuum, that's probably going to have a negative effect, because fuel mileage, some guys think that they're equating their fuel usage to fuel mileage. That's not accurate. If you're driving around and in the throttle a lot, that's not driving for fuel mileage. Driving for fuel mileage is driving for fuel mileage, meaning very minimal throttle input, and ideally out on the freeway, like a sustained running at some fixed speed. Or you get even better mileage if you don't run a fixed speed, like you're going the same speed up a hill as you are down a hill. You actually adjust for those. You don't go as fast up the hill, and I actually don't go as fast down the hill if I'm trying to get better fuel mileage. So you drive for fuel mileage. So, but if you're going to compare one versus the other, you need to do that as a regimented test. You have to drive exactly the same. And most people can't do that. So they go, oh, my fuel mileage was terrible with this new cam. Yeah, because it makes 50 or 60 more horsepower, and you're enjoying that 50 or 60 horsepower much more, because the single biggest thing that you can do to change fuel mileage is the way that you drive, much more than a camshaft. TFS high ports on 347, it's all about the flow. That's right. Those will support a 347, as we know. The 4V heads make a huge difference. Yeah, a 4-valve 4.6 is better than a 2-valve 4.6. bought a 406. I'm thinking about twin turboing. That's good for anything that comes after the. I'm thinking about. I just bought a whatever, and I'm thinking about adding turbos. The poll is up already. Where can I get old school big block Chevy fuel injection stuff? Only thing I see is Edelbrock stuff. There are other options. Look at Arizona Speed Marine. They had some good stuff. I like your analogy for fuel mileage. Well, it's, I get terrible fuel mileage. And that's the guy to see in a truck with big tires, whomping on the throttle all the time, running around. My fuel mileage is terrible. Yes, it is. I helped restore a 1970 Dodge Coronet 440 Auto B5 Blue a few years ago. Sold a couple of years ago for 20 grand. Nice. I should have said I wanted 500 horsepower and 30 miles per gallon. Yeah, that's a little harder, but not impossible. Just got to add boost. Had so much E85 my oil, it was losing lifters, getting terrible mileage. Oil change fixed that. It does. My truck is now at 330 or 40,000 miles. It gets fuel in the oil now. I'm sure it's getting tired. So, but regular oil changes do improve it, because I start seeing the change in oil pressure also. Y'all don't know 441 with AFR heads and a Torker version 2 is good for 30 miles per gallon in a truck. Sure, I'd like to see that. My supercharged Pontiac gets 31, or it can be 11. Yeah, it can be both of those, right? I found I get better mileage with the vehicle with a larger engine than one that has a small one. I don't know how that's possible, but if you have done a regimented test, I'd like to see that. Didn't Jim finally break down with the advent of the rec port and at least internally call the Gen 5 the LS Mod Windsor? I don't understand any of that. What's the difference between a 406 small block Chevy torque motor and a 455 rat motor? Well, it's 50 or so, a little less than 50 cubic inches. So the big block would definitely make a lot more torque. How many 460s in the 300,000 miles? Just two. It had the original one in it, and then it broke when I was towing the Omni out to Ohio. Still partial to the inline 6-cylinder, but a V8 is great. It is. One of the tests that I want to do with it, and it would be hard to do, but I would like to run that 300 inline 6 Ford, and I'd like to compare it to a V8, because I just want to show people that the inline 6-cylinder motor doesn't make more torque. That torque is a function of displacement. Speaking of fuel mileage, that's why I was thinking about a 4.8 with a torque cam and boost to make up for the power when needed. That is good. A turbo under cruise should not hurt fuel mileage, but it will under power because it's much richer. Why are you doing the Dodge Omni? You mean because it's awesome? I think it's two. I mean, I haven't owned this truck the whole time. We thought that the one that came out of it was the original one, but this doesn't necessarily had to have been. They used to have vacuum fuel mileage gauges in the 80s and 90s. That actually makes a really big difference in the way that people drive. If you put a gauge on there with a needle that shows good fuel mileage and bad fuel mileage, people will drive differently when they have that gauge. I have a 69 Blazer with a 427 big block in it. Like to convert to fuel injection, but don't want to LS swap it. But if I do, I'll be looking at an 8-liter 496 with a turbo. The 8.1 is the 8.1 that we ran is a good option for that, especially with boost. Better comparison is a 4-cylinder versus a V6 or inline 6 in the same size vehicle. I don't know about what a 4-cylinder should get better mileage than a 6-cylinder. It has less friction. Always hear people telling me that LQ4 and 8.1 get the same mileage in a similar setup. I don't know how that, like I said, don't know how that's possible. And the people that when I hear things like that, those are the guys that I see driving, not doing fuel mileage tests. They're just driving the way that they drive. So we're at 57%. The closer to wide open throttle you can run an engine at the exact same load, the better the mileage is. Well, only because you're getting rid of the pumping losses. But you need to discuss the way that the manufacturers allow you to get rid of those pumping losses, because it's pretty complex. It typically, with 99.9% of the vehicles out there, the higher the vacuum reading, the better fuel mileage it will get. Canned 150, you have a 351 board 30 over flat top pistons. Do the pistons have valve reliefs in them? Victor Jr. heads, maybe ported Victor Jr. heads would be a little bit better. I don't know what intake manifold you have. 500 horsepower is going to take a pretty good sized cam in a 351. It's not going to be drivable. I don't know if you're racing that. Going too small on displacement will work the engine hard, resulting in poor fuel mileage. But here's the thing that people don't seem to understand, that cruising down the freeway, depending on how big your vehicle is, like in the Civic, in the Civic VX, admittedly an extreme example to the efficiency side, took 11 horsepower. So to make 11 horsepower, I could have done that with a Predator engine. And so figure that's, 30, 40, 50 foot-pounds, depending on whatever your vehicle is. So you can, so then the argument would be, if you have a smaller engine, you would have more throttle angle and less pumping loss to make that 30 or 40 or 50 foot-pounds that you would need to make just to sustain cruise. Like I said, the most of the people that I see, when you see a truck, if you see a V6 version of a truck and you see a 4-cylinder version of a truck and a V8 version of the truck, I don't think I've ever seen any fuel mileage rating that was done in a structured thing where the 4-cylinder got worse fuel mileage than the V6 did or the V8 did, because the truck was big and it took more throttle or whatever. I just have never seen that. I'm not saying it's not true. I'm not saying that you didn't get better fuel mileage or worse fuel mileage or whatever. I'm just saying it goes against all of the data. Have you seen any newer Chevy 2.7 liter 4-cylinders? I haven't looked for them, so I wouldn't know. Yes, they have valve reliefs. It doesn't have to be drivable. Okay, so you can put a big cam in it then. So you could put a 248, 254 cam in there. Probably won't need something that big to make 500 horsepower. I'm talking real world driving in traffic. See, that's the thing. You're throwing in the variable of how you drive as the thing. So that's not a fuel mileage test. ICT. I've seen guys put the Predator engine in different cars, trying to get really high fuel mileage. And if you want to, there are lots of good like fuel mileage videos that guys have done, like the hypermiling guys. You get on the hypermiling forums or what, if they still have that, or groups, whatever they're called. You can see the guys are get really serious about it. It's aero mods, lowering it, belly pans. One of the good ones is extending stuff off of the back shelf so that you taper the airflow down into the vacuum area behind the car, the low pressure area. That's really good to do. Getting rid of all the parasitic losses. Don't drive the alternator. Definitely don't drive an AC. Two ring pistons. All of these things to try to help the thing not have losses associated with doing anything but getting the vehicle to be driving down the road. Fuel mileage is largely aero driven. It's some aero driven, but it's also like pumping losses in the motor, and there are lots of things, because if you're trying to get good fuel mileage, first of all, you're not running lots of vehicle speed, so you're at 70 miles an hour or less, and the lower the speed is, the better you are for fuel mileage. Yes, and friction is mileage. I had on both on the Civic and on the little Chevy Sprint Turbo, I had low rolling resistance tires. We pumped up the air pressure in them, and you do all those things, change the alignment specs, all of that stuff. President Reagan was right. 55 is the best fuel mileage. It's 55 is better than 60 or 65 or 70 or 80, like a lot of people drive. Does SCTA have a Predator class? Yeah, they have very small displacement motor classes, but not a Predator specific. So I don't know what the displacement is on the Predator. But they have, Cushman out there running, golf cart, all kinds of stuff. I got less than 4 miles per gallon towing my RV with a small block 350 at 45 to 55 miles per hour. See, I don't know, when you say 45 to 55, that's a really big change in fuel mileage between those two. If you were driving at a steady state 45 versus driving at a steady state 55 on the freeway or wherever you were driving, those would be dramatically different in fuel mileage. Our truck, our big block, carbureted big block truck, used to get 5.5 to 6 miles per gallon on the freeway, and we were only going 60, between 55 and 60, depending on what kind of hills and stuff we were going on. But we would do it long distances. We would go from the time that we would fill the tank up, we would get on the freeway, because we used to have to drive to these big races and stuff. And we would drive and try to get good fuel mileage. And we'd be driving at that vehicle speed. And it would get 5.5 or 6 miles per gallon towing our race trailer. Use octane booster on my 08 Ford 150. It helps with fuel mileage. So maybe it's adding timing to get the extra fuel mileage. Washing your car gets better mileage. It takes weight off, it improves aero, makes you feel better about it. So we're going to close our poll out at 56% saying no, they don't want to run the stack injection. Maybe don't want to run it open. Maybe don't want to deal with the problems. So you're going through a quart of oil every gas tank. I don't think even the LSs are notorious for using oil. And I was trying to think about how much oil I used when I went back to Ohio, but I didn't use a quart every tank. That seems like it's excessive. Depending on the car, some cars get better mileage at 45 and some get better at 65. I'd like to see any vehicle that gets better mileage at 65 than it does at 45. I don't know how that's possible. The aero drag would be dramatically different going from 45 to 65, and the RPM would be lower. Everything about that which should be better fuel mileage at a lower engine or a lower vehicle speed. Does compression affect fuel mileage? Yes, it does. The direct injection stuff gets pretty good fuel mileage, I think. One more minute. We degraded, and not degraded, but we transitioned. Went off on a tangent on fuel mileage, which is good. That's good, great stuff. The same RV towed 9 to 13 miles per gallon that comes. Yeah, I remember being at the races and guys with turbo diesels were complaining, yeah, I only got 14 or 15 miles per gallon on their new turbo diesel, whatever. I'm like, dude, that's 3 times what we got on the way out here. I get over 20 on my Silverado. See, I don't get 20. Mine gets 19, 18, high 18s, 19, and that's at a sustained 70-mile-an-hour cruise going down the freeway. It is 4-wheel drive, but I'd like it to get over 20, but it doesn't do that. What do you think of factory tune port injection? Like the old L98 stuff? I got lots of videos up on it. You could see what they do. How was 8 wideband readings on the XS manifold with different runner lengths compared to a stock LS3? A stock LS3 is terrible for individual air fuel per cylinder. It's awful, as most factory ones are. I know that you would think that they would be optimum and they would be ideal, but they're not. A tune port 91 is good on fuel, has extra long gearing at 259. It's just ticking over. We ran 8 widebands on all of the intake manifolds. So I have all of the air fuel data, individual cylinders on all of the intake manifolds. And the stock LS3 is not good. You would think it would be, but it's not good. They all get better at the top of the RPM range. But you would think with a factory one, it would be perfect all the way up, except that the factory one was never designed to run on a 427 with a gigantic nitrous cam and lots of compression and all of that stuff, and headers and all that. So, but even on when we tested like the factory 5.3 stuff, the factory truck manifold was not good either. It was not. I thought it was going to be even, but it was not. You ever tested a dual quad cross ram on a big block Chevy? I have not. I've never run, I don't think, a cross ram, a dual quad cross ram on a small block or a big block. But on that note, it is time to go. This was good stuff, but I'll be back tomorrow. I have to figure out what video I'm doing now. I have 2 of them that I'm looking at. I think we're going to go away from the intake stuff for a little bit and then do some different stuff and then maybe come back to it later on. I want to do one on the 8,000 RPM 5.3 that I was doing way back the last time that I went out there. And then I'd like to do something on the Brian and James did the L83 head and cam and intake manifold and header upgrade on the Gen 3, Gen 4 stuff. So I'd like to do a video on that because I think that that's kind of cool stuff and see how it compares to the regular Gen 3, Gen 4 head cam and intake kind of thing. So that'll be an interesting deal, but all that will have to wait at least until tomorrow.